Good morning everybody, and in this class I'm going to cover the BIOS dissection and deassembly process. In my previous class I had covered one part of the IO controller, but I have chosen this topic to explain it because this is one of the major problems faced by the technicians while repairing the current type of board, where we have two kind of ICs, BIOS ICs, EC BIOS and system BIOS. But when you try to find the BIOS backup on the official website, you get an exe update, and you may try to unzip this exe update by 7-zip, but when extracted with software like 7-zip, you find a .fd files or some files, but the size of that fd file is sometimes larger than the actual required size, or sometimes smaller than the actual required size, or when you require both EC and system BIOS separately, there is a together the both are combined file. So we need to devise certain approach, certain techniques to deassemble that file and get our required size. So in this class I'm going to discuss the approach and techniques, and please note the approach and the techniques will vary with model and model wise, right? So here we will discuss some 3 to 4 dissection and deassembly, and after going through this 3 kind of dissection and deassembly, you will have a fair idea of how to dissect it, how to deassemble it with the other models. Okay, so this is one of a very important class, and you may have to rewind this class many times to understand it, because certain things may not be clear when you go through the first videos playing, right? But when you rewind it, you'll get it everything. And now the classes will be more faster, and I'm trying to finish this class in around 15 days. So let's just start with the today's class of BIOS dissection and deassembly process. To start with this class, we'll need some more softwares, and let's see what are the required softwares. Okay, so we would require some kind of software for this dissection and deassembly process, and one of the very important software for it is Ultra Edit. Okay, so let's open this Ultra Edit. You can download this Ultra Edit by searching Ultra Edit in Google, or I can give you a backup of the software Ultra Edit. This is basically a hex editor, and we'll go through what is actually a hex editor is. Let us open this. So this is Ultra Edit 32, and this is a very fine hex editor. And this hex editor, you will find many things for edit, because basically we have to go through these functions of this editor, and the functions are, let us first convert it into hex. Okay, let's go and open it into the, right now we have to just open one file. So let's open one file to show you. Okay, this is my folder, and in this folder I have put everything Ultra 32. So let's open this. We'll go here and open this file. Yes, but you see this is looking very tedious. You cannot see anything. So here there is one function in edit, and you type hex edit. Now this file is looking very good, right? And to explain hex, let's first go through what exactly is an hexadecimal format, right? So let's check here. This is a hexadecimal number system. Well, to simplify things, let me explain first what is the difference between a binary number system and hexadecimal number system. See, our processor, the processor in a notebook motherboard, or processor in a desktop motherboard, or processor in a mobile, they don't have much brain, you know. These are man-made, so they don't have much brain, so they cannot decipher very complex sentence. The processor are based on very simple approach, true and false. they will check any scenario with condition whether it is true or whether it is false. So if true, they will do this action. If false, they will do this action. So true and false, only two states a processor works in, that is 1 and 0. So in computer hardware, on digital computer architecture, we use binary number system to represent data, right? And as you know, 8 bits is 1 byte, whereas in hexadecimal number system we use hexadecimal number system to represent that data, because in hexadecimal, when we use hexadecimal number system, then the entire data is compressed. We can represent that same data in less space, right? Because you see, the hexadecimal number system is similar to decimal number system. The decimal number system is 0 to 9, 0, 1, 2, 3, 4, 5, 6, 8, 9, 10 digits, 10 numbers. But in hexadecimal numbers, it is same, but you see, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, this is 10, 11, 12, 13, 14, 15. But in here the decimal number system ends, but in hexadecimal number system we go till A, B, C, D, E, F. So we find we can represent the same data in binary with hex in less space. So we use hexadecimal number system to represent data. Alright, you got my point? Now there is a very easy way to convert a binary number into a hexadecimal number. Let's see. As you know, a byte is 8 bits, so let us consider 8 bits. Okay, 0, 0, 0. This is how much? 1, 2, 3, 4, 5, 6, 7, 8, right? This is 7, 8. This is 1 bit. Now we have to convert this into hexadecimal number system. So how do you convert? See, you choose right from the right side. 1, 2, 3, 4. This is 4, right? Put a space. Now you convert this into decimal number system, right? You can convert into decimal number system. You know how to convert this? Let us convert 0, 0, 0 into decimal number system. This is binary, right? This is binary. So we have to convert it into decimal. So how would we convert? Convert, you know, 0 wait, 0, this will be all 0 in decimal. And how do we convert this into decimal? 0, 1, 2, 3, that is 1 into 8, 1 into 8 plus 0 plus 0 plus 0, right? So this will be 8, right? 8. So we can write in hexadecimal as 80. You got my point? We have to convert this 4 bits into decimal, and we have to convert these 4 bits into decimal, and we can write here, and this is hex format. The entire binary format has been converted into hex format in only 2 characters. You got? So this is why we use hexadecimal to represent data. But in actual format, binary system is used by processor, because processor works on logic of true and false. Also this binary number system is used to prevent the data loss or data corruption, because suppose if 1 byte is moving from this chip to another chip, what maximum can be done? 0 can get converted into 1, or 1 can get converted into 0. But we can check whether this error has caused with help of parity. I won't go into much detail what exactly is parity bit, but you can search in Google why parity bit is required and how it helps in letting us know that the data has been corrupted. Here the main significant point is we convert the binary form into hexadecimal form to analyze the data. Okay, so let's go back to the Ultra Edit software. In Ultra Edit software, you'll find, we'll go click edit, you will find many options over here. For us, the important options is hex, insert and delete. You'll find here options insert and delete. So if you put your cursor over here and you want to delete data up to here, right, then what you have to do, you have to edit, hex insert delete, and then you have to enter data, and it will delete the values after the mouse, right? The data after the mouse will get deleted, whatever values you put over here, and rest data would shift here, right? So we'll use this software to dissect and deassemble the BIOS. And for me, I have many important case study over here, but we'll cover the case study like Dell 5520, V3450, 6930P, E325. This 4 case study will cover in the today's class, and the rest we'll cover after the finishing of IO controller, maybe if we get time. So by this 4 dissection and deassembly process, you will have a fair idea of how to do it. Okay, so let's open our PowerPoint presentation, and this is E325, IBM E325, and in IBM E325 we have 2 kind of BIOS chip. One is the system BIOS, and another we have EC BIOS. The system BIOS is W25Q16. Q16, that means it will have 2 MB of file. Alright, you divide it by 8 in the W like format, you divide it by 8, you will have 2 MB of file. It will have a 2 MB of file, required file is 2 MB. While it has an EC BIOS MX25L512, and it will require a 512 KB of EC data. Alright, so let's see the IBM E325. There is another way to extract the IBM files, but that is only valid for the older version of IBM. Since when IBM was overtaken by Lenovo, the Lenovo has used its own way to pack these 2 BIOS file, and they now pack it in little complex way. Earlier the IBM was packing the BIOS in a very simpler way, and we can extract this data with one command like ex file. We could have extracted this file with ex file, but now the extraction is a little bit more difficult. So we'll take the case of IBM E325, that is IBM Lenovo E325, and we go to my folder, and my folder is here, IBM E325. When we download the BIOS update from the website, we get a file like 8nuj13us. Let's delete it so that you could be understanding this. Alright, let's close it again. Be very specific and precise. We get this file 8nuj13us. Now this file is 5 MB, right? 5 MB, and our and you see in our presentation we have 2.512. The total, if we add it, 2 MB and 512 KB, it's around 2.5, less than 2.5, right? So there must be this file. If we extract this file, we might get, so we get an idea that yes, this exe update file would have these 2 files together, because this file size is greater, you see, 5.029 MB, whereas our required is around 2.5 MB. So that means we have to extract this to get these 2 files. Alright, so extracting is very easy. You just double click it. Alright, double click it. Next, we'll go next, no problem. We'll follow all these steps. Here you can change the extraction, because we'll not go into the C driver. Let us browse this and we change it to our location, and our location is desktop. So I'll go to the users and use this one, and we go to desktop, and this is my folder, and we go to IBM 325. Okay, we go to next, install, and you see my folder is extracted. Let us check out and finish. So this is our folder. We double click the folder and we find two files, right? There are no such related files over here. So you find the 8NET37WW and there is 8SET34WW. What does these two files represent? This 8NET37WW is for Lenovo E320. There are two models coming in IBM Lenovo, E320 and E325, and this is 8SET Lenovo E325. So we double click it and this is our file. This is our file, right? So we will copy this, all right, and we will put over here, all right, and now we'll open this with hex editor, with our favorite hex editor. We'll open it with Ultra Edit. Double click it and let's open this file, and our file is saved here in E325. This is our file. We open it, right? Let us rearrange it in hex edit. Yes, now my file is hex rearranged. So what we have to do is, we know in a very interesting point that I will tell is, you have to note this thing is, in this kind of file, first BIOS is there and after that EC is there. That is, first the BIOS file is there and after that EC file is there. In every kind of exe update, when you extract exe update and you get such kind of file, .fl1, please kindly note, in IBM Lenovo, .fl1, this format, .fl1, this is the main file that we have to work on, not any other file. This is the main file that we have to work on, .fl1. And note, you'll find many kind of extension like .fl1, .fd. In any kind of this files, first the system BIOS is there and after that EC BIOS is there. So what we require is, we require the 2 MB file, right? We require the 2 MB file. So we'll go in the Ultra Edit and we'll go till 2 MB. Let's go, where is our 2 MB? We have to 2 MB would be where this is 2, it will come 2 over here, right? So let's go to 2 MB. Wait, 2 MB. Move downwards. Yes, we are reaching to our 2 MB. That is the system BIOS. We are reaching. Yes, wait. Yes, this is, we have to go ahead. 2 MB, right? And this way you have to, this is the approach of dissecting the BIOS. Here you have to be very cautious, because anything that you delete would make this BIOS corrupt and it will simply destroy your system. So you have to be very cautious when doing this, and it will require some practice, and you can try practicing it on your computer. Let's find our 2 MB file. Yes. So here, data from the starting to here is 2 MB, right? Data from starting to here is 2 MB. So rest data we have to delete, right? Because this is useless. Our system BIOS is only 2 MB. So what we'll do is, we'll put the cursor over here. We'll put edit, hex insert delete, select delete, and you put as much values to delete. You can put something like this, 189.345.6. all right, and you got this file. Everything is deleted. You see, everything is deleted up to here. Now this file, you can save this file as, you can save this file like E325 system BIOS, that is smbios.rom, and you see it in your folder of IBM 325. You see this is 2048 KB, that is 2 MB. How this is 2 MB? You see in the calculator. Let's use the calculator, and wait, my system is little slow, and we'll use calculator to explain each and everything. This is calculator 2 MB. In 1 MB, you know, 1024 KB. So 2 into 1024 KB, that is 2048 KB, right? And 1 KB is 1024 bytes. So we multiply by, sorry, this is byte, 2048 KB. You see, this is 2048 KB. So our system BIOS is 2048 KB, that is 2 MB. So we got our system BIOS. Now the question is to remove the EC BIOS, right? Now the question is to remove our EC BIOS. So we'll remove the EC BIOS. Now we'll remove our EC BIOS, right? In here, in our Ultra Edit, we'll go back, we'll open our earlier file, right? This set, this file, we'll edit, we'll go to the hex edit. This is our original file, right? This is our original file. Now what we have to do is to remove our 2 MB system BIOS. So the remaining would be EC BIOS, right? Remaining would be EC BIOS. Let's go and find the calculator. 2 MB is how much? 1024 KB, right? And if we multiply by 1024, we'll get that much byte, right? So this is our byte. 2 MB is 2097152 bytes. So if we delete from here 2097152 byte, we'll get our EC BIOS. So what you have to do is very simple. Edit, hex insert, delete, put the values 2097152. All right, this is the value, and you put OK. Now this, you save it. You've already deleted, okay, and you save this file here in E325, and this is your EC BIOS.rom, and you open this folder, EC BIOS.rom. Well, this file is little less than 512 KB, but a very important analysis if you do with the EC embedded controller is that they read the data sequentially. So the size is not important for the EC BIOS. As of now, the size is not important for the EC BIOS, but the system BIOS size is really important. So this is EC BIOS.rom. This is the actual EC BIOS.rom, and you can run this file in the EC BIOS and it will work perfectly. So this is the BIOS dissection and diassembly for the Lenovo E325. Kindly note, we require the .fl1 file to deassemble and dissect it, and I would try to give credit to one of my friend for this help, because I was trying to dissect and deassemble a different file and I could not find anything in that. And thanks to Mr. Lee, he is living in Shandong province of China, and a great credit to him for helping me out this, and thank you to him. And in Chinese I can say "谢谢" to him. So let's go back and see our another BIOS dissection file. In this thing, I think you are very much clear. You have to rewind this. We have extracted this because this is 5.029 KB, whereas we require 2 MB and 512 KB together. They are less than this update file. We have extracted this file. We have found two folders. This is E320 and this is E325. Here we are considering about E325. So we have opened this. we have copied this over here and we have opened it with Ultra Edit. And as I told, in this kind of file the system BIOS is first and after that EC BIOS is there. So I have selected first the 2 MB file. I have gone to 002 up to there. I have selected that data, deleted the rest. That is our system BIOS. We again reopened this file and we deleted the 2 MB. 2 MB is 201024 KB is equal to 201024 into 1024 bytes. We have deleted that bytes. Rest file is EC file. This is very simple. So I have started this with a simple procedure. In the next BIOS dissection, that would be little tedious. Okay, so we have another, let's see another file for BIOS dissection. And we have an interesting case study of Lenovo Dell 5520, Dell Inspiron 5520, also called as Dell Inspiron 15R, and this is a very common model. And in Dell Inspiron N5520 we have two kind of BIOS chip. One is system BIOS, that is W25Q32, that means it will have 4 MB of file. And EC BIOS, this is MX25L160E, that is it will have 2 MB of file. But if you download the BIOS update from the website, you will find it as 4.34345 KB. That means this update is compressed. These two files are compressed together in one update file. So we need to first extract this compressed file. We double click it. Yes, and we'll go to see it in the temp folder. Do not click OK. If you click OK, the extracted file will go away. So we'll go to the C drive, we'll open the users. Okay, users, we open the users, we go here and you see there is a hidden folder, app data. Inside it we go to local, and in local we have to go into the temp folder. In the temp folder you see there is extracted 7Z-S9C3G. You double click it and there would be .fd file, and this is our .fd file. So this is the important one. We copy it and we'll paste it over here in our folder Dell 5520 and you paste it. This is our file. Okay, this is our file. Okay, so now we have extracted the .fd file from the BIOS update that is present on the official Dell website. So you can see this file is 6.26272 KB, right? And our file needed is approximately same, that is 42 plus 6. So we can notice that this is the file we are looking for, and we will extract the system BIOS and the EC BIOS from this file. So let us open our software Ultra Edit. Okay, we'll open the Ultra Edit to extract that file. Alright, this is a very good hex editor. We will open this file .fd. Yes, but please note there's an interesting point over here. In .fd file, usually in Dell, the first 128 KB is header file. So we have to delete the 128 KB, that is header file, right? You can see in the calculator, wait, in the calculator, we can see 128 KB is 1024 bytes, that is 131072. So we'll place the mouse over here, starting point, and we'll press edit. Then we go to hex insert delete, we'll choose delete over here, and we'll put the number 131072. So we'll delete the 131072. Very cautious here, and we have deleted it. Now we can save this file as biosback.rom, and this is our file. From this file we have to extract the 4 MB. As spoken, the first 4 MB is system BIOS. So we'll select the first 4 MB and delete the remaining to get our system BIOS. 4 MB is 00, you see 00H2 003 3FF. You can see over here. You can see over here. we'll select the first, okay, E, F, 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 yes. We'll go down, all right, F3FF. The first 4 MB is system BIOS, so we will select the first 4 MB, delete the remaining and save it as system BIOS.ROM. okay, system BIOS.ROM. so we have to follow very smoothly, no error. Yes, we'll put our cursor over here, right, and the data above this address is system BIOS, so we'll delete the remaining data. You go over here, hex insert delete, put values as much as it deletes the value, right? Still not deleted remaining, so we'll select again, we'll find 1 3 5 6 7 8 9. Alright, so all the data is deleted after that. Okay, so this is our system BIOS. You can save it as system BIOS.ROM. okay, and you see in the file, go here, del 5520, and you can see this is system BIOS.ROM. okay, 4 MB file, 4 into 1024, that is 4096 KB. You see, this is exact system BIOS.ROM. Now what we'll do is we have to extract the EC file, right? We have to extract the EC file. So we'll open again our Ultra Edit, alright, and we'll open again that our file.fd, yes, alright, and we'll delete the 4 MB data. So what we'll do is 4 MB of data is how much byte? You use calculator. 4 MB is 4 into 1024 KB, right, multiplied by 1024, that will give you bytes. So 419434, you delete 41, starting 419. As I have said, the first 4 MB is system BIOS, the rest is EC BIOS, right? Rest is EC BIOS. So we are deleting 419404. You delete over here and you can save it as now as EC BIOS, EC BIOS.ROM, and you can see EC BIOS is 2176 KB, right? 2176 KB, 2 into 1024 is 2048. So this is little bit more. This 2176 KB is little bit more, but I said the EC BIOS is done sequentially, right? Is done sequentially. So some BIOS programmer will handle this file with no problem, but some of the BIOS programmer will throw error. So what we will do is after 3FFH we'll delete the values, right? You see, some BIOS will give you no error. So this is EC BIOS, right? So we got EC BIOS and system BIOS. Well, some programmer may sometime give you error, but not with this del 5520. I've never observed with this, but if they give you some error, then you have to delete the file after 2048 KB, right? So this is the way we have got EC BIOS and system BIOS. And we will take another case of, let's go back to our PowerPoint presentation. What is our next case? And our next case is 6930P. So we'll follow the 6930P case. Okay. Okay, so now let us see the HP6930P. This is also very interesting kind of case study with us, because there is little differences from the earlier two dissection that we have done, the earlier two dissection separation we have done. This 6930P is having one system BIOS chip, that is SOP8W25Q32 SPI 32. That is, this is 4 MB BIOS, 4 MB BIOS chip, right? So what we will do is, let's this is an EFI BIOS. So in case of EFI BIOS, always remember you have to take backup from the chip, from the BIOS chip of the notebook motherboard. So here, and how you can take backup, the best way to take backup is to use programmer. So by using programmer, we'll save the original BIOS as biosback.rom. You got it? This is an EFI BIOS. So in case of EFI BIOS, we have to basically use little content of the original BIOS file. So what we'll do is, we'll take the, you see here we have written, we need to first back up the original BIOS file present in chip and save it as biosback.rom. Okay, now we download the exe update file. If you will extract it, and by extracting it you will find two files, that is sp45530d.exe, sp45530u.exe. D is for discrete, U is for integrated. Discrete means separate graphic chip, integrated means all integrated. So here we are dealing right now with discrete. So you double click this .exe and a rom.rar file will appear, and we know very well we can extract this rom.rar file with WinRAR. So extract it with WinRAR, you will get rom.bin, but the size of this rom.bin file is very less. It is very less as compared to the requirement of 4 MB. So what we will do is, we'll open this rom.bin with our ultra edit. You see, we'll open this with ultra edit. Let us open any file for just sake purpose, because I don't have right now the, we'll just open this one right now, the backup, the original backup of 6930P. So we have opened it. Let's close the earlier thing. Okay, so we have opened this and we'll copy all this. Let us consider this to be rom.bin. So if this is rom.bin, we'll copy all the data. We'll copy all the data. Okay, and now what we'll do is, we'll open the biosback.rom. What is biosback.rom? We have copied the original BIOS file from the chip using processor. We'll open this biosback.rom. We'll pull the cursor to 254x0h address and we'll paste the data of rom.bin. We'll paste all the data from the rom.bin, and you can see the cursor will be at this address, and you have to delete the remaining and save it, and this is our original system BIOS file. So you see, we are using the back.rom file, you know, rom.bin, what we have extracted rom.bin file, it is very less in size as compared to our requirement of 4 MB BIOS. That means we have to use the original backup to add it and make our system BIOS chip. So what we'll do it, we'll open this rom.bin, we'll copy all the data, we'll again open this biosback.rom, we'll go to 2508 address, we'll paste it, and we'll delete all the data after 400H, because we require data up to here. This is our 4 MB. This is our 4 MB data. All right. This is our 4 MB data. So, and we will delete all the remaining data and we'll save. And this is our system BIOS file.
Now we'll consider, this is one example of how to handle an EFI BIOS. In the next case study, I'm going to handle the Dell Vostro 3450 BIOS, and there we can see a little more complex when we have an EC BIOS also. So let's go to our next case study and check Dell Vostro 3450. Alright. So now let us consider the case, our next case, that is Dell Vostro 3450. This is, see, I have tried to move sequentially using all the concepts. First I have tried with a very easy IBM 325, then I have moved to Dell 5520, then I have moved to 6930P, a little EFI, right, that was EFI, and now I have come to Dell Vostro 3450. This is an EFI system BIOS plus EC BIOS, right, plus EC BIOS. So what we'll do is, let us consider this Dell Vostro 3450. In Dell Vostro 3450, you have two kind of chip. One is the system BIOS, that is MX25L3205. This is system BIOS. 32, that means 4 MB file. EC chip is W25Q40, that is 512 KB EC BIOS. Now what you will do is, when you download this file, when you download the BIOS update file from the website, and you see in the property this is 9.63 MB, quite horrible. We require just 5 MB and this is 9.63 MB. So that means we have to extract BIOS from this. Alright. So let's check our folder. We'll go to the I'll go to my desktop and open my folder, and BIOS dissection and diassembly. We'll go to 3450. Here is, let's close all this. Okay, here is our exe file. You can see in the properties. All right, you can see in the properties 9.63 MB, quite horrible. We require just 4 plus 4, close to 5 MB, right? We just require close to 5 MB. You see, 512 KB, right? Less than 5 MB, but the exe update is 9.63. all right, 9.60. so what we have to do is, we have to extract this. So let us put double click, okay, and let the system respond. Yes, it has extracted. You see, it has extracted, and we will get this file bios1.wph from here, and we'll copy it and we'll put it back in our folder, that is BIOS dissection and diassembly. Put it over here. Now this is close to our requirement. So what we'll do is, we'll open this with Ultra Edit. Wait, let us close this. All step by step, you can try yourself. Sorry, this will open, and this is our dissection Vostro 3450. Will open this. Alright, and what we'll do is, we will delete the datas from 00. Wait, we'll delete the data. Just follow over here, and we'll delete the data from 00A0H. We'll delete the data from here to here. You see, we'll delete the data in this from here to here. We'll just delete this data. Select and delete this data from here. A0H, alright. 00A0H. 00A0H. You see over here. A0H. So we'll delete this data. That is the surplus data, because what our requirement is 4 MB and 512 KB. So we'll just cut out. Now our cursor is over here. We can save this. Just save this. Alright. Now this is system BIOS plus EC BIOS. So what are the steps? We will have to just move our cursor to 3FF over here. 3FF 4 MB. The first 4 MB is system BIOS, rest is EC BIOS. But then again there is a little twist. So let us first just extract the EC BIOS, then we'll talk of the system BIOS, because this is EFI, so we have to do something with our BIOS backup of the chip. Alright, let us first do our step. We have to extract the first 4 MB for the system BIOS, rest is for the EC BIOS. So we'll go to here 3FF. Alright, closely we have to just follow closely, no missing. If you delete anything, your yes. So what we have to do is we have to delete the data after this. Then the top 4 MB is our system BIOS. The top 4 MB is our system BIOS. So what we'll do is we'll just go here, we'll do insert, delete, and we'll put value, any value that can delete data is up to here. You see all the values deleted, and we can save it as system bios.rom. Alright, we have saved this as system bios.rom. Alright, let's close this and let's open again our WPH. Alright, let's go to hex edit, hex edit. Alright, and now what we'll do is we'll just delete the 4 MB and the remaining would be our EC BIOS. Same procedure like we have done it, right? Same procedure like we have done it. We'll just, this is all procedure we have done till now, and bios.rom. Now we'll delete 4 MB. 4 MB is how much? Let us use our calculator. 4 MB is how much? 4 into 1024 KB into 1024 bytes, that is 4194304. So what we'll do is we'll just delete, we'll put the cursor over here on the top, we'll delete, hex insert, delete, choose this, and 419, where is our calculator? 4194304, and just put it. Now this is our EC BIOS, but our EC BIOS has to be 512 KB. So what we can do is after this value we'll get the real EC file. Some BIOS programmer can program this EC BIOS. Let us save it as, first save it as EC BIOS. Some BIOS program can program, but this file, you can see this file is more than this, right? More than 512 KB. So what we will do is we'll delete the data after 8, that is 512. 8, we'll delete the data after 8. You see here, let's go to 8. Triple times 0, 8. This we're reaching. Here we'll delete the data from down, then we'll get our 512 KB. So what we'll do is again we'll go here and we'll put values 3, 4, 5, 6, 7, and here is our data. Now this is our real EC BIOS. save, right? This is our real EC BIOS, save as, okay. Wait, EC BIOS, save as, yes. Now we close it. You see our EC BIOS is 512 KB. Finished. We have got our EC BIOS 512 KB. Now this EC BIOS has nothing to do with the EFI. So now the question is, we have got our system BIOS, but this is not EFI compatible. So we'll follow again the procedure over here in a PowerPoint presentation. Till now we have got our EC BIOS, alright? We have got our EC BIOS. Now what we'll do is, it is also, you see, for V3450 for EFI BIOS file, it is necessary to read out the original BIOS chip data file, right? We have to read out the original chip data. Now what we'll do is, we'll just open our saved 4 MB file. We'll just save our 4 MB file. We have to open again our Ultra Edit, and we have to open again our Ultra Edit. Alright, and we'll open our system bios.rom that we have saved from this, okay. System bios.rom, we go to hex edit, yes, and now what we'll do is, say the mouse is now we'll delete this much byte, 1572864. What is this? 1572864 is 1024, right? This one is KB 115. So we'll delete this data, 1572864 byte from this, 1572864 byte from this, hex delete 1572864. This I have basically doing cross back, but I am writing it over here. You can see actually I have to make 4 MB, so I am adding this, deleting 1572864. We delete this data, and we got this, okay. We got this. Now what we'll do is, you follow the next procedure. Select all. We have to copy all. All right, we have to copy all, select all. We have selected all, and now what is our next step? Our next step is to open the original BIOS, the original BIOS backup that we have taken. We have to take this original BIOS backup from the programmer. We go to the address, this one, and we have to paste all the data which we have copied till here, we have to paste this data, okay. And then we have to delete all the data after 3FF, that is the 4 MB. This will give us EFI system BIOS. Alright, this will give us the EFI system BIOS. So what we have done here is, first let's start from the very first. Let us start from the very first of E3450. We have noticed that in Dell Vostro 3450 we have two chips. One is the BIOS chip of 4 MB and the EC chip of 512 KB. The BIOS chip here is an EFI BIOS chip. So as seen in the previous case of 6930P, we have to do something with the original BIOS. We have to take backup of the original BIOS, and you can take backup of this original BIOS through programmer. Now we have downloaded the BIOS update, and you can see the BIOS update that we have downloaded is close to 9.63 MB. That means we have to extract this. So after extracting this, we got BIOS 1.wph, which is close to our file. So we'll open this, and we have deleted the initial A0H, and this is 5 MB file, close to 5 MB file. So that is what we are requiring, 4 MB plus 512 KB. Now we have got this file. We'll select the data as done in our previous case. We'll select the data from 00H to 003FFH, right? We'll select this data from 003 to 3FFH, delete the remaining and save it as BIOS system bios.rom. Okay, now we'll again open this wp1 the BIOS wp1, right, and we will delete 4 MB, initial 4 MB. As I have said, in this kind of file we have first system BIOS, then EC BIOS. So we will delete this 4194304. How this number has come? 4 MB, 4 into 1024 KB into 1024 bytes, that is 419430 bytes. So we have to delete it, and we have got the EC, but EC should be 512 KB. So what we'll select, we'll delete the data after this 800H, and we'll get the 512 KB of EC BIOS. Now what we have to do is we have to change this system bios.rom, right, because we have to make it as EFI compatible. So what we will do is we'll open the system bios.rom. All right, we'll delete this much of data, 1572864 byte. We'll select the remaining, all right, and we'll open the original BIOS chip. We go to over here 18000H, paste it. Our cursor will go down over here. We'll delete the remaining, and this will be our 4 MB system BIOS chip. All right, so I think I'm pretty much clear, and I will cover the deassembly and dissection of around 5 more models, and in that models we have 4010 is one of the model. We have 1535, 1435. We have Lenovo, some more Lenovo models and ASR models. But right now I'll just cover another topic, that is the HP DMI utility. There has been a lot of confusion regarding this tool, when to use this tool and how to use this tool. So let us go to HP DMI utility. This is a very good utility provided by HP. Sometimes what happens is when you flash BIOS of HP laptops, or when you change motherboard of suppose you change motherboard in HP laptop, then some error would occur, like OS cannot be installed, So in that case, what we do is we have to restore the asset, that is through HP DMI utility. And where you can download this HP DMI utility, we have backup of this HP DMI utility. It's there with me, and I can share with all of you. HP DMI tool. This is HP DMI tool, but this HP DMI utility will only run in DOS mode. So what you have to do is you have to take a pen drive, make it DOS bootable, copy this HP DMI utility into that, because it cannot run directly into your Windows. This utility you cannot run into your Windows. You have to run it into DOS mode. Before going into that, let's check what important thing is there. Yes, and you see this kind of tag we have. This is model number, right? This is model number. This is the part number. This is the serial number. All right, this is the serial number, and you may find something like this where the serial number is at the top and this is the product number, or you may have something like this where this is serial number and this is product number. So these are the 3 kind of tags present in the HP. Let's go to the next slide. As I said, you cannot enter, you can download this HP DMI or NBDMI Fit, that this tool is called, from our website CHIPTRONIKS.com. But before running this, you have to make a USB bootable pen drive. You have to copy this, and then you can run your laptop into DOS mode, right, to boot from the USB, and then you can type at the command prompt NBDMI Fit, and when you type this interface would be there, 013457, like this. 0 is for serial number, 1 is for notebook model. Let's go to the next slide. 0 means display and set host serial number, the host serial number. 1 will display the machine model, as we have seen. Let's go to the next slide, previous slide. You see this is serial number, this is model number. Okay, so you see 3 is display and set UUID model. 4 is for display and set SKU model code. 5 is for display and set in CTO region code. This is for region code, like whether this laptop is in China, this laptop is in India, this laptop is in South Korea, this laptop is in UK. There are separate region code, and you can find in Google, and you can put the CTO region code over here. If a laptop is for India, you have to put the region code for the India. Alright, and this is for display and set PCID, product configuration code, and like this. Let's go to the next slide. We press 0 and we have to put the serial number over here. Serial number you can get at the tag which I have shown in the previous slide, right? You have to put serial number and you have to put 10. In some cases the string length varies, like in some models you see earlier, in some model this is 10 and this is also 10. Maybe in some model this may be less, something like 6 or 7. Then you have to change the string length over here. You have to change the string length over here. Alright, so next, go to the next level. We then press 1 to enter the model. What is exact model? Here, if this is compact processor CQ35, put compact processor CQ35. With the motherboard is of CQ40, you put CQ40, or DV6, you put DV6. Alright, then we press enter and you have to write the UUID, and below that there will be one option, press 1 to generate automatically. So you just press 1 and it will generate automatically. Press 4 to enter display and set SKU model code. So you can just put the SKU model code. Similarly CTO and remaining also you can find, like PCID, product configuration code. This is very important, and you can find it on your close to your RAM slot in the motherboard, this PCID, right? Or you can, if you don't find, then you have to just put a string of around 17, right? 17 characters. Just put any string of 17 characters over here. Alright, so we have finished up with the today's class, and in the next class I will cover with the remaining part of the IO controller. I will finish it up. We'll go to the PCH, then CPU, the complete process we cover, the CPU voltage regulator will cover, all the things we cover, and then we move back from CPU to PCH to IO. That is the BIOS booting process. That is very important, and will follow with oscilloscope. And my target is to complete this course in another 15 days. Thank you. And if you have any problems or questions, you can always email me. Please rewind these videos 3-4 times and you'll get an idea. This is just an approach, no methods. There is no methods to disseminate and dissect BIOS file. That is an approach. For each kind of model you may have to do something much different, but the approach is same. The approach is same, the technique is same. Thank you everybody.